So now we're going to take a look at some examples to where we have indistinguishable objects. So suppose we were to select the jury from a pool of 8 men and 9 women. I want you to notice that the men and the women, although the groups are distinguishable, the people that contain that group are not distinguishable. So we just know that there are just 8 men, 9 women. We can't tell the men apart from one another. Okay, so in this group, a man just means it's a man, and the 9 women, they're interchangeable. So in this case, we would have to use combinations. Okay. Remember in the previous example, we had O-W-N-E-R-S-H-I-P, which means there are 9 different letters. In this case, there are 17 people, but they're basically going to be about the same except for the 2 different groups. So, how many different 5-man juries can we create? So, there are 8 men, and of those 8, we want to select 5. So, let me make my 8 look like an 8. Sorry about that. So, we have 8 men, and of those, we want 5. Now, in the calculator, what we're really going to do is we're going to compute 8 combination 5. All right, so that's what that notation means. I'm going to go ahead in the calculator, and I wind up with 56. Okay, so regardless of who those men are, there's 56 different ways that we can select them. How many 5-woman juries can we create? Well, that's going to be 9 women, and of those 9, we want 5. So again, sticking that in my calculator, I end up with 126. Right. Now, what if it doesn't matter about men or women? What if it's just people? So, how many 9-person juries can be chosen? That must consist of 4 men and 5 women. All right, so this is the multiplication rule. And the reason it's a multiplication rule is because we have a number of ways of selecting men and a number of ways of selecting women. The 9 in this case is inconsequential because 4 plus 5 is going to give us the 9. All right, so in this case, the 9 really doesn't matter. It's implicit for us. All right, to be able to figure this out, there are 8 men, of which we select 4. There are 9 women, of which we are going to select 5. 8, 4 in the calculator is going to give me 70. And we just computed 9, 5 in the previous problem is 126. And so the product, I get 8820. Right. And again, just verify this in your calculator. Make sure that you're okay doing these sorts of problems. Right. Letter D. How many 7-person juries can be chosen? That must consist of 3 men and 4 women. All right. So once again, we're going to do the exact same process. So now we have 3 men. So remember, there's 8 men. We want 3. There are 4 women. So that of the 9, we want 4. All right. So in the calculator, we're going to go ahead and compute. So 8, 3, I get 56. And then 9, 4. I get 126. I want you to notice that that 8, 3 is the same as 8, 5, and 9, 4 is the same as 9, 5. A little bit later, when we start talking about the binomial theorem, we're going to see why this occurs. There's actually a symmetry with respect to this binomial distribution, or this sort of the combinations. So, multiply 56 and 126, and I end up with 7056. All right. Now, what if we want a 3-person jury, and it must consist of at least 1 man? Okay, so we have to be careful with this one. So let's see what at least 1 man means. All right, so I'm going to copy and paste these. And again, just like we saw earlier with the copy and paste, this is really letter E, and this is really letter F. All right, so now be careful with this because it says at least one man, and it's up to 3. So there's actually 3 possible outcomes. All right, there's a scenario where we have 1 man. There's a scenario where we have 2 men. And then there's finally a scenario where there's 3 men. All right, and we only go up to 3 because it says a 3-person jury. At least 1 man means at minimum. All right, so we have to be careful when we're computing this. Now, don't forget that if we're selecting men, we also, by default, have to select some women to fill out those 3-person juries. So, for the first one, we have 8 men. We want 1 of those. By default, there are 9 women, and we want 2. So 1 man implicitly means 2 women. Similarly, if there are 2 men, that implicitly means there is 1 woman. So that would be 8 men, select 2, 9 women, select 1, and then finally 3 men, 8, 3. Implicitly, that would mean that there are 0 women out of 9 that we're selecting. So we're going to compute these. All right, now some of these I can just do really quickly. So 8, 1 is 8. 9, 2, I think that's 36, but I'm going to just check that. So it is 36. 8, 2, I believe that's 28, but let me verify that. So that's 28. 9, 1 is 9. 8, 3 we looked at earlier. I think that was 70 or it's 56. Okay, so 8, 3 we looked at, we got right here. So that's 56. And then 9, 0 is 1. All right. Now, at least 1 man means 1 man or 2 men or 3 men. So what we're going to do is we're just going to add these together to be able to get to the total number of ways. So just bear with me one moment while I type this in my calculator. Again, if you would check this just to make sure, I ended up with 596. So be careful with these at least problems. All right. Now, one final example that we could utilize this methodology, or we could use a little bit easier way, which I'll show you in a moment. I'll show you both ways, is how many 7-person juries can be selected that consist of at least 1 woman. All right, so I'm going to copy this down here. All right, so there's 2 ways to do this. There's a painful way, and then there's a not so painful way. And we're going to do them both. All right, so at least 1 woman. Well, that means that there could be 1 woman, 2 women, 3 women, 4 women, 5 women, 6 women, and then finally 7 women. All right, so that would be pretty tough to do. Another way to think about this is, what if we took the total number of 7-person juries and then we subtracted no women? That would be another way to do this. So, or we could just take total number of 7-person juries, and from that we would subtract 0 women. All right? So we could do it either way, but I think the second way is a little bit easier. All right, now we know that there's a total of 18 people. All right, remember 9 men and 9 women, 8 men, and of those we want 7. For 0 women, and remember we're picking 7 people, that would be 8 men we want 7. 9 women, we want 0. Right? So that's one way to do it. Another way to do it is to brute force it and just do all of these. Okay, so for instance, and I'm not going to write all of these out, but just maybe the first and the last one. Remember, there's 8 men, and if we want 1 woman, that means we want 6 of the men, and then there are 9 women, we want 1 of them. Right? And then for the last one, that would be 8, 0, and then 9, 7. And we'd have to figure out all the ones in between here to be able to get to the answer. All right? So computationally, that would be pretty brutal. All right. Now, I'm just going to go ahead, do 18 combination 7, and I'm going to subtract. Well, actually, let me just do them in steps. So 18 combination 7, that gives me 31,824. I know 8, 7 is 8. I know 9, 0 is 1. So if we subtract those, we end up with 31,816. For practice, what you could do is you could compute all of these, all right? And what you would end up with is 31,816 by doing it the brute force method. All right, so sometimes we have to be very sneaky about trying to compute for the at least problems when we have a larger sample. Okay, with only 3 people, it's not so bad, as we saw in letter E, but in letter F, it becomes a little bit tougher.